some of the ideas you're coming up with here. Okay, so let's go ahead and start at this table. Okay.
Break down.
Okay. So can I ask you to select a couple of the ideas you came up with? What would it mean to simplify, or what would you want kids to potentially be able to think about for simplifying? So let me start here. What might that mean?
We can break it up the question. After, I'm not going to touch the question by itself, and then I'm going to make some bullets. First, how many blocks total? I can ask those kind of scaffolding questions.
Okay, so scaffolding question is something to consider here, right? As a route. Okay? What else? What's another way that you think you might be kind of helping kids to think through it? What about this table? Simplifying assumptions. What do you think?
Figure out the unit.
What do we mean by unit?
Per block. How much it would cost to travel.
So finding a cost per block?
Right.
Generally, it's guiding questions. Providing guiding questions.
So it's kind of still within that scaffolding questions, right? It might be still actually within that. Is that kind of what you're saying?
Yes.
Okay. Okay. What else? What else might be simplifying assumption for these kids? Yeah.
Yeah, some leading questions such as is Dora mom gonna pay or not? What do you think? You know, is a round trip or the $300 only for one side or a two-sided? It's a round trip. These are the questions make them clear.
So these are questions, right? Clarifying questions, right? So what else might be strategies to think of as simplifying assumptions?
Maybe using charts, or let us say, what are your different choices? Plan A, Plan B, Plan C. Give them graphic organizer.
Okay.
Round trip is not assumption. It is there, but it's hidden in a 5 sentences, one word return, and kids gonna skim through. So you want to highlight the keyword. So we have to really search for it to see is a round trip or return, and it was there. It's not assumption, but it's just that.
Okay, so that's an interesting point, and I think that came up here too. Right, so one question might be, does it matter, and what becomes a simplifying assumption around that question? So it may be that that within problem solving we're listing questions and then answering them with with something that makes it simple. Okay, so I'm gonna also just share a few thoughts on this. I could imagine kids saying, wow, do we have to sit through and think about 180 days of school? Or does it not matter and I can really just think about one day of school? Right?
It's at the end of the term.
Is it?
Didn't think about it.
Pardon? End of the term. So what's a term? Okay, so good point. So term. Maybe term's 90 days. What's a term? Or in problem solving, is it a simplifying assumption for me to say, you know what, I'm just going to think about one day? Does that simplify the problem? Could I change this problem to only involve 3 kids or 2 kids? Would that be a route to simplifying this problem? Right? So, you know, would that be something that would help them? Let's think about that picture. When we think about that picture, what if we took Laura and Chan out of the problem and just talked about this as Jason and Jason's mom doing the driving? Right? Is that a way to simplify kids thinking about this problem. Right? So what do we mean by simplifying a problem when we're thinking about problem solving?
Sometimes problem solving, you use a small numbers to understand the big numbers problem. So in this case, if you want to start to give a right direction, you can make a problem by giving them a blocks in words. You can say that 4 blocks and 2 blocks, they are paying total $200, how much each block costs. Something like that. You're using a small number to lead the problem.
So would it simplify anything for students if they said, you know what, let's just pretend that this was about $1, not $300? Would that simplify things for students to think about? How much sense should each of the 4? Okay. So we've got a few ideas about what simplifying might mean. Andrea, any other things you want to share having done this problem in your classroom?
Well, I think also some of the confusion on the original problem had to do with thinking that the 3 quotes given by the students were somehow mutually exclusive, that they couldn't all be correct in their commentary. So, for instance, the first quote says, I think Laura should pay the most as she has had further to travel. The second one says, yes, I think we should share the cost according to how far we travel in the car. So that is actually in agreement with the first bubble or quote. And the third one says, the people who are in the car for part of the journey should share the cost equally for that part. So in a sense, when we do find the answer, all 3 of these are still true. So I think sometimes students assume that there's only one person who can be right. And that's not always the case. It really, the answer meant all that criteria.
Okay. So there's some interesting things about this problem. Some of us may not have even turned the page yet.
That's
to
the
see.
first part.
So, right, with the 3 people responding. Thank you. Right, so are these mutually exclusive is kind of what you're talking about here, right? And letting kids kind of debate that. Are they going to be able to, how do we encourage them to be comparing routes through solving this, right? Okay, we're going to kind of shift gears now. Okay, so I think, again, some of the questions that we're putting out here are, is this a problem? How do you think about a problem like this versus a problem like the consecutive sums problem? If you were making a choice about, you know what, first, second day of class, what's the kind of mathematical activity that I might want to have kids working on? Okay, and these are 2 different routes that you could be kind of thinking about with this curriculum. Okay? Okay. Okay, so now we're going to shift gears. This is not in your binder. We kind of added this in, especially just looking out of some of your feedback yesterday. And I think this could be something that we make sure we're doing every month, right? These 3 questions are taken from the Compass kind of practice problems that they make available. So these are some samples Compass problems. Now, as a couple notes, when students are taking a Compass exam, one of the strategies that's really essential for us to tell our students is that it's to their best advantage to take as much time as possible when they're starting problems, because the test kind of grades them as they go. They'll be given one problem on a computer. If they get that right, it takes them one route. If they get that wrong, it takes them a different route. and the advantage to their score is best by getting the first problem right. So they don't need to feel rushed. They should not feel rushed in doing these problems. Okay? So, what I'd like you to do at this point is to read your problems. Actually, let's make this group a little bit bigger. Okay? Can I just have
2 more people?
yeah, 2 more people, maybe move from there to there. Just so that then we've got a group of 4. Great. Okay. Okay, so what I'd like you to do is go ahead and read. I'll read the problems out loud, just because it's a little squinty in it. Okay? And then here's what I want you to be kind of talking about at your table. You could either be picking one of these problems, or you could be thinking about 2 or 3. But what are some teaching techniques that you have to share about what becomes effective to help students work and succeed on a problem like this? Okay? Okay, so actually, Andrew, you want to read the first problem in a nice projecting voice?
So, so the first problem, 4 students are going to purchase concert tickets for $18.50 each, but they discover that they can purchase a block of 5 tickets for $80. How much would each of the 4 save if they can recruit a 5th person to join them, and the 5 people equally divide the price of the 5 ticket block?
Okay.
Is that clear? The second one, on a math test, 12 students received an A. This number is exactly 25% of the total number of students in the class. How many students are in the class? And the third one, this year, 75% of the graduating class of Harriet Tubman High had taken at least 8 math classes. Of the remaining class members, 60% had taken 6 or 7 math classes. What percent of the graduating class had taken fewer than 6 math classes?
Okay, so what I'm asking you to do is to first be maybe thinking about the struggles that you anticipate students having, and then what would be some of your own teaching strategies, okay, to help students with that problem, these problems. Okay, so kind of sharing in your groups to start.